Have you ever stopped to ask yourself why we all think we understand the world? Yet the moment we peek beneath the surface, things feel wrong, like there's a deeper layer that doesn't obey the rules we learned in school, or the ones our common sense swears by. Quantum physics is a perfect example of this. It doesn't just bend the rules. It shows us that our instincts about how the universe works are often misleading. And yet, the basic ideas are not actually beyond comprehension if you're willing to think carefully and patiently. Let's start simple. Imagine a single particle, say an electron. In classical thinking, we might picture it like a tiny billiard ball, moving along a path that we could, at least in theory, track. We'd say it's here, it's moving this way. We could measure its speed and position. But quantum physics says something startling. That's not the whole story. An electron doesn't just exist in one place at a time. Instead, it has a range of possibilities, a kind of spread-out presence, a haze of probabilities. Pause for a second. Does that actually make sense? If you're like most people, it doesn't. But think about it another way. Imagine you're trying to find a friend in a dark room, and all you have is a flashlight. You sweep the light across the room, and sometimes you see them, sometimes you don't. The friend's position isn't definite until you look. That's not just metaphor, it's literally how nature behaves at the smallest scales. And here's the uncomfortable truth. Most of our everyday intuitions are completely unreliable when applied to the quantum world. The universe is not obliged to make sense to us, and it's tempting to impose simple narratives where none exist. That's why the first step in learning anything deep, whether physics, investing, or decision-making, is admitting what you don't understand. Avoiding this admission is one of the most ways people fail. Now let's explore a peculiar property called superposition. In classical thinking, a light switch is either on or off, but a quantum particle can exist in a state that's simultaneously on and off until measured. It's not that it's hidden or we lack information. The particle genuinely embodies both possibilities. Only when we measure it does it choose one outcome. Why does this matter outside of physics? Because it's a reminder that certainty is often an illusion. Most people live their lives reacting to events as if outcomes were predetermined or fully knowable. In reality, probabilities dominate, and the wise move is often patience and careful observation rather than blind action. This is one of the most powerful rules wealthy, successful thinkers follow. Avoid stupidity before chasing brilliance. Reacting emotionally or prematurely is usually more costly than waiting. Let's test this idea with a simple thought experiment. The famous double-slit experiment. Picture a wall with two narrow slits, and we fire particles at it one at a time. If particles behave like billiard balls, you'd see two clumps behind the slits. But the experiment produces an interference pattern, a hallmark of waves. Yet here's the kicker. If you measure which slit the particle goes through, the interference disappears. It behaves like a particle again. The act of observation changes reality. Take a moment. That's deeply counterintuitive. It suggests that our classical notions, what things are independently of us, break down. Yet the math behind it is clean, precise, and consistent. It's not magic. It's a reflection of how the world truly works, not how we wish it worked. And there's a practical lesson hidden in that subtle truth. You can't afford to rely solely on appearances or conventional wisdom. Instead, you must understand the mechanisms, the incentives, the cause and effect relationships beneath the surface. Here's another uncomfortable truth. Most people overestimate the role of brilliance and underestimate the role of patience and preparation. Quantum mechanics is notoriously difficult to learn superficially because every shortcut leads to misunderstanding. But if you build slowly, piece by piece, using what you truly understand, you begin to see clarity. In the same way, long-term success, whether in thinking, investing, or personal growth, comes not from clever hacks, but from careful, consistent reasoning. Now consider entanglement, a property that even seasoned thinkers stumble over. Two particles can become linked, such that measuring one instantly affects the other, no matter the distance separating them. Einstein called it spooky action at a distance, but it's real. And it's another example of how the world refuses to conform to simple intuitive rules. There are consequences for how you think about causality and connection. You can't assume things are independent just because they appear so. This leads us to a deeper reflection. If the universe operates on probabilities, not certainties, and if observation affects outcomes, what should we focus on in our own decision-making? The answer is surprisingly simple. Minimize errors you can control. Think long-term and recognize the limits of your understanding. These are the same principles that govern success in many domains. Most people lose not because they lack intelligence, but because they fail to invert problems, to ask what mistakes am I likely to make, and how can I avoid them? Let's test this idea with an everyday analogy. Imagine walking on a busy street blindfolded. You might think speed is your advantage, but the smartest move is to move slowly and carefully, observing the patterns of traffic. The quickest person often fails. The patient, cautious observer succeeds. In quantum physics, as in life, impulsive action rarely wins. Another truth that feels uncomfortable: complexity and noise are everywhere, and reacting to every signal is how people get trapped in perpetual failure. The universe doesn't reward busyness or emotional reaction. It rewards patience, insight, and understanding of the underlying rules. In quantum terms, it's as if you are constantly measuring the system too early. You collapse possibilities before you've learned what's really happening. As we near the end, take a moment to reflect. The most powerful ideas in quantum mechanics are not about memorizing equations or pictures. They're about understanding the nature of knowledge itself, that certainty is rare, that observation matters, and that probabilities govern outcomes. These lessons extend far beyond physics. They apply to how we think, how we plan, and how we avoid the trap of reacting to the wrong signals. So what's the final takeaway? The world is not intuitive, and shortcuts are often dangerous. Curiosity, patience, and honest reckoning with what you don't understand are your greatest assets. By exploring the quantum world carefully, step by step, we discover something profoundly human. That wisdom often comes not from brilliance, but from restraint, not from reaction, but from reflection, not from chasing glamour, but from avoiding stupidity. And maybe, just maybe, if you slow down enough to think clearly, you start to see the world a little more as it really is, not as you wish it to be. Let's go a bit deeper, and this is where most people stumble. Not because the ideas are inherently complex, but because they try to force the world into familiar patterns too early. Take the famous quantum measurement moment. We've talked about particles existing in multiple states at once, only deciding upon observation. But why does observation matter at all? What does it mean for a particle to choose a state? The uncomfortable truth is this: nature doesn't care what we expect. Measurement isn't magical. It's a physical interaction. When we check a particle, we're not just looking, we're interacting with it, nudging it into one of its possible states. Think about it like this. Imagine a delicate spider web. You can't tap it lightly with a finger without disturbing the threads. Measurement is a nudge, not a passive glance. And it changes the outcome in a predictable, measurable way. This brings us to another principle. Small actions can have disproportionate effects. In life, this is often counterintuitive. Most people assume large efforts produce large results, and small efforts produce small ones. But the world doesn't always reward size. It rewards precision, timing, and understanding of structure. In quantum physics, observing at the wrong moment completely changes what you see. In life, acting without understanding often guarantees failure, no matter how much energy you put in. Now let's examine probabilities a little closer. In classical thinking, probability feels like uncertainty, born from ignorance. Flip a coin, you don't know the result until it lands. But in quantum physics, probabilities are not just about ignorance. They're fundamental. They represent the very nature of reality. A particle genuinely has a range of outcomes. It is not hiding some secret true position. Does that feel uncomfortable? It should. It forces us to confront one of life's quiet truths. Certainty is often an illusion. Most decisions we make, most plans we execute, contain more uncertainty than we admit, and yet most people behave as if outcomes are predictable, and the world should bend to their will. This is exactly why avoiding stupidity is often more important than chasing brilliance. You can't control the universe, but you can avoid predictable mistakes. That's leverage. That's a kind of intelligence that compounds over time. Let's explore one more idea that tends to break intuition: interference. We touched on the double-slit experiment, where particles create patterns like waves. But why does this happen? Think about waves in a pond. If you throw two stones, the ripples interact. Sometimes they cancel. Sometimes they amplify. In the quantum world, particles interfere in the same way, not because they're literally two waves, but because each possibility interacts with the others. It's a kind of internal consistency. Now here's the real kicker. You cannot fully separate possibilities from outcomes. Each potential path the particle could take talks to the others, even if only probabilistically, and this has a mirror in life. When we consider multiple options or scenarios carefully, we can see patterns and risks that would otherwise be invisible. Most people react to the immediate outcome without considering how unseen factors interact over time. That's a recipe for repeated failure. Consider another uncomfortable truth. Our brains are wired for stories, not for probabilities. We see patterns, assign causes, and tell ourselves simple narratives to reduce discomfort. But in quantum mechanics, the simplest story is almost always wrong. Reality is probabilistic, counterintuitive, and often uncomfortable. To understand it, we need to fight the urge for immediate emotional explanations. That's not a flaw in intelligence. It's a flaw in human nature. Recognizing it is one of the most underrated skills for thinking clearly. Let's pivot slightly to entanglement again. Two particles, far apart, can be correlated in ways that seem instantaneous. In everyday thinking, this feels impossible. We're trained to assume that distance breaks connection. But truth and physics shows that nature doesn't care about our assumptions. Connections can exist beyond our classical intuitions. Here's a life lesson embedded in that. Relationships, incentives, and cause and effect often extend far beyond the obvious. Most people fail because they assume independence, where there isn't any markets, societies, personal networks. All these systems are entangled in subtle ways. Recognizing hidden connections allows for better decisions, but it requires a willingness to think differently from the crowd, and that's uncomfortable. Most people prefer easy explanations, even if they're wrong. Now let's confront another misconception: the idea that genius is a shortcut to mastery. In quantum physics, the geniuses who made breakthroughs weren't simply brilliant. They were patient, meticulous, and willing to follow the logic step by step, often into areas where no one else dared to go. Speed, shortcuts, and superficial cleverness produce confusion, not clarity. The same is true in thinking, investing, and learning anything deep. Another uncomfortable truth: most people overvalue action and undervalue observation. You see this in everyday life all the time. People react to news, trends, or peer pressure, believing movement equals progress. But in quantum experiments, the act of interacting prematurely collapses possibilities. In life, premature action without sufficient observation often collapses your potential outcomes. The world rewards the patient observer, not the frantic actor. Let's take a moment to reflect on the broader picture. Quantum physics doesn't just teach us about particles, it teaches us about how to think, step by step, patiently, respecting uncertainty, observing carefully, avoiding obvious boasts. It's a mirror for rational thinking. And here's the quiet, almost uncomfortable truth: the rules are simple, but the human mind resists them. We crave certainty, narrative, and shortcuts. The universe doesn't comply. So what should we do? Start by embracing what you don't know. Approach complex problems as experiments, not as battles to win immediately. Minimize errors, recognize incentives, and think long-term. Understand probabilities dominate outcomes, and your control lies in careful reasoning, not in force or instinct. Most people act emotionally, fail predictably, and then blame the world. You can choose differently. Consider the idea of opportunity cost. In quantum physics, choosing one measurement collapses other possibilities. In life, every action has a cost, the cost of the opportunities you forego. Most people never account for this. They act as if doing something is inherently better than doing nothing, without comparing what they might lose by acting. That's a subtle but profound insight. And it's exactly the kind of thinking that separates long-term thinkers from the reactive majority. Another subtle but crucial point. Randomness is not the same as chaos. Quantum events are probabilistic, but they are governed by precise laws. Life is similar. There's randomness, noise, and uncertainty, but there are also patterns and principles. The key is to learn the rules, observe patiently, and avoid predictable mistakes. Acting impulsively in the face of probability is a guaranteed path to failure. Acting thoughtfully, even when outcomes are uncertain, compounds advantage over time. Finally, let's consider reflection itself. Quantum mechanics forces us to reflect on the limits of knowledge. Observation changes reality. Uncertainty dominates. Probabilities govern outcomes. And every intuitive shortcut is likely wrong. That's uncomfortable, but it's also liberating. It tells us that mastery is not about knowing everything. It's about understanding the edges of your knowledge and acting wisely within them. And that perhaps is the most profound lesson quantum physics offers, beyond particles and waves. The rules of thinking clearly, avoiding predictable mistakes, and acting with patience are timeless. They apply to physics, yes, but also to decision-making, investing in life itself. Most people ignore them because they are uncomfortable, subtle, and slow to reward. But if you take them seriously, you begin to see the world with a clarity that others almost never experience. In the end, understanding quantum physics in this way isn't about equations or abstract mathematics. It's about learning how to think in a world that resists your assumptions, where outcomes are probabilistic, observation matters, and nth beats raw speed. And once you internalize that, you start to notice patterns everywhere in life, in society, in your own decisions that most people miss entirely. The universe is stranger than your intuition allows. And yet, by moving carefully, observing patiently, and reasoning honestly, you can navigate that strangeness more successfully than almost anyone else. That is the quiet power of understanding reality, the way it actually is, not the way you wish it to be. And that perhaps is why only this kind of thinking, slow, patient, careful, grounded in first principles, can make quantum physics feel simple, even elegant, to someone willing to pay attention. Now let's take a moment to confront one of the most uncomfortable realities. Most people misunderstand what intelligence really is. When we think about genius, we imagine sudden flashes of brilliance, insights appearing fully formed. But in quantum physics, and in life, the truth is far more subtle. Intelligence is often less about flashy ideas and more about the patience to follow logic carefully, the discipline to observe without bias, and the courage to admit when you don't understand something. Consider a single electron again. You might be tempted to ask, what is it really? And that's exactly the trap. The question assumes the universe should conform to your intuitions. But in reality, the electron doesn't behave in ways we expect. It doesn't have a hidden classical identity waiting to be uncovered. Instead, it follows probabilistic rules that are consistent, precise, and observable, but counterintuitive. Most people fail to see this distinction and end up inventing comforting narratives that are, in fact, wrong. This is why avoiding stupidity beats chasing brilliance. In everyday life, most losses come not from failed opportunities, but from predictable mistakes that anyone paying attention could avoid. Just as in quantum experiments, where measuring too soon collapses possibilities, reacting impulsively in life collapses potential outcomes. The world doesn't reward recklessness, and yet that is the default human tendency. Now let's explore a subtle but powerful insight, what quantum mechanics teaches us about cause and effect. In classical thinking, cause and effect seem straightforward. If I push a ball, it rolls. If I eat, I gain energy. But in the quantum world, outcomes are tied to probabilities, observation, and entanglement. A single measurement or a single decision can ripple through a system in unexpected ways. Think about entangled particles again. One measurement influences another, even at great distances. In life, too, actions are rarely isolated. Your decisions, however small, are part of a network of interactions, social, economic, and psychological, that can amplify or suppress effects in ways that defy intuition. The uncomfortable truth: you are never acting in a vacuum, and most people fail to account for that. They underestimate the hidden connections, the unseen dependencies, the compounding effects of seemingly minor actions. Let's make this concrete. Imagine you're trying to save time by multitasking, jumping from one task to another without pausing to plan. The intuitive sense is that movement equals productivity. But just as in quantum systems, collapsing possibilities too soon, reacting without observing, creates interference. Tasks overlap, errors compound, and outcomes are worse than if you had proceeded deliberately. The world doesn't reward busyness. It rewards correct alignment of effort and understanding. Here's another discomforting insight. Randomness is not a flaw in the universe. It's not chaos for the sake of chaos. In quantum mechanics, probabilities are precise, mathematically consistent, and governed by rules. Similarly, life is full of randomness, but the patterns of probability remain, acting as if outcomes are certain, or as if you can predict everything, guarantees mistakes. Acting with patience, observation, and respect for uncertainty multiplies your advantage over time. Now consider the idea of superposition once more. A particle can exist in multiple states at once until observed. Translate that metaphor into human thinking. Often our decisions have multiple potential outcomes, each influencing the others. Yet most people collapse possibilities too early. They commit to one narrative, one plan, one strategy, without fully exploring alternatives. By contrast, the most effective thinkers maintain options, monitor results, and let reality guide them. That's not indecision, it's disciplined patience. Here's another truth that feels uncomfortable but is critical. Emotions are the enemy of clarity. Quantum physics doesn't care about how you feel. Reality operates according to precise laws, probabilities, and interactions. And yet, human beings consistently inject emotions, biases, and wishful thinking into decisions. Most failures, financial, personal, strategic, come from overreacting, assuming certainty where there is none, and ignoring the limits of understanding. Avoiding emotional reaction is often the single most reliable path to long-term success. Let's pause and test this reasoning with a thought experiment. Imagine a particle in a superposition of two states. If you rush in to check its state without patience or strategy, you force it to choose prematurely. Similarly, in life, when we rush decisions, jumping on trends, reacting to headlines, or chasing quick gains, we collapse our own potential. The optimal strategy is often to observe, gather information, and act with precision. The impatient mind fails. The careful mind succeeds. Now let's confront another uncomfortable truth. Complexity is inevitable. The universe isn't simple, and neither is human life. Most people underestimate complexity and overestimate their ability to predict outcomes. Quantum mechanics teaches us that the deeper you look, the more interconnections, probabilities, and uncertainties emerge. Attempting to simplify too aggressively leads to errors, just as ignoring the rules of physics leads to failed experiments. The lesson: respect complexity, but don't be paralyzed by it. Use careful observation, reasoning, and incremental action to navigate the system effectively. Consider one more analogy. Picture a river with multiple currents and hidden eddies. You want to travel downstream efficiently. The naive approach is to push forward blindly, assuming the path is straight. But a patient observer notices patterns, predicts interactions, and avoids obstacles. In life, in thinking, and even in markets, most people behave like the blind paddler. They react emotionally and fail to account for underlying currents. Success is rarely about speed. It's about understanding how the system works and acting wisely within it. Here's an additional subtle point. Systems often resist simplistic measurement. The act of probing too aggressively can change outcomes. In life, this is why micromanagement, overanalysis, or emotional interference often backfires. The world responds to your interventions, sometimes in ways you cannot foresee. Just as in quantum mechanics, the solution isn't to avoid action, but to act deliberately, informed by observation and principle. Now let's tie this back to human behavior. One of the most neglected principles in thinking clearly is inversion. Ask what not to do. In quantum terms, which measurements will ruin the outcome. In life, what mistakes are most likely to destroy progress? Most people focus on chasing success, ignoring the far more reliable method, avoiding predictable failure. This is why rational patience beats impulsive brilliance, and why the smartest thinkers focus on avoiding stupidity first. Another uncomfortable truth: progress is often invisible at first. Quantum phenomena don't reveal their secrets immediately. You must accumulate observations, refine understanding, and wait patiently. Similarly, meaningful decisions, learning, and long-term success accumulate gradually. Most people abandon patience for the illusion of instant gratification, misunderstanding the slow compounding of rational action. Finally, consider this. Quantum mechanics forces humility. It reminds us that reality operates independently of our preferences, biases, or assumptions. The universe doesn't reward ego or wishful thinking, and yet most people plan, add, and invest as if the world were aligned with their hopes. The quiet power comes from aligning with reality, not forcing reality to align with you. Observation, patience, careful reasoning. These are the tools of anyone who wants to succeed in a probabilistic, interconnected world. So as we step back, the pattern becomes clear. Quantum physics isn't just about particles, waves, or entanglement. It's a mirror for disciplined thought. It teaches patience, humility, and precision. It rewards observation over impulse, understanding over intuition, and careful alignment over raw effort. Most people ignore these principles because they are uncomfortable, slow, and counterintuitive. But if you internalize them, you see patterns and opportunities where others see confusion. And here's the final insight. Learning to think this way, to navigate uncertainty patiently and rationally, is a form of mastery more valuable than any specific knowledge. Quantum physics is just the lens. What it teaches about probabilities, observation, patience, and avoiding predictable mistakes applies to life itself. The universe is stranger and more precise than our instincts allow, but careful reasoning, observation, and humility let us navigate it far more effectively than emotion, ego, or wishful thinking ever could.